You're here because you want to learn about air in the atmosphere with a University of Cambridge graduate. Let's begin. Hi, I'm Brendan, and I've been helping students like you achieve their mastery over chemistry over the past 8 years, and I hope that you can learn something from me today. Before we begin, be sure to go into the link below so that you can download a free copy of my notes and use it to follow through our lesson today. So this chapter is going to focus a lot on our atmosphere pollutants. Okay, by definition, these are substances that are present in our atmosphere that can harm living things or damage non-living things. Now, it's very important that as we go through each of our pollutants, you need to memorize, and I mean memorize everything that you see. You need to memorize all the sources of all these pollutants, and you need to memorize all the consequences of these pollutants in great detail. Okay, I cannot stress this enough. This is very, very important. Okay, and if you don't memorize it, you'll never be able to answer any of the questions moving forward for air and atmosphere. Our first pollutant is going to be hydrocarbons. So a source is these unburned hydrocarbons, right, usually come from your internal combustion engines due to insufficient oxygen or insufficient time in the cylinders. So it usually goes through incomplete combustion, right? And another source of hydrocarbons is a very common one is methane. Methane comes from bacterial decay of your vegetable matter in stagnant water. Okay, and this usually comes also from rubbish buried in landfills. Okay, so the consequences of these hydrocarbons are that in the presence of sunlight, right, these unburned hydrocarbons will combine and react with ozone and oxides of nitrogen to give rise to this thing called photochemical smog. Okay, and these photochemical smog causes respiratory illnesses and actually the tearing of your eyes as well, which is very annoying. The next pollutant is your nitrogen monoxide or your nitrogen dioxide. These are your oxides of nitrogen, right? The source is that these actually come from the reaction between nitrogen and oxygen from the air due to, keyword, high temperature in the internal combustion engines of your cars. Right? Whenever you have a very, very high temperature, right, you're able to break the very strong N triple bond N, okay, in your nitrogen gas. And once it does that, your nitrogen becomes very reactive, again, react with oxygen in the air to give you oxides of nitrogen. So two reactions happen, N2 plus O2 to give NO, okay, nitrogen monoxide, or you can get NO plus O2 to give nitrogen dioxide as well. And another source of your oxides of nitrogen is the reaction between nitrogen and oxygen due to lightning activity. Again, because of the same reason, it's because of the high temperatures as well. The consequences of your oxides of nitrogen is, as spoken about just now, okay, it can combine with your ozone and your unburned hydrocarbons to give photochemical smog. Okay, and this is the greater detail that you don't really have to know, right? But this will obviously cause you respiratory problems and the tearing of your eyes. Not only that, your oxides of nitrogen also dissolve in rainwater to form nitrous and nitric acid. So these are the two equations over here, right, that you could very well be tested on. Okay, and these always result in acid rain, right? And we'll talk about the consequences of acid rain later, but it's important to know, okay, how your acid rain is being formed first. Okay, so we've been talking about ozone already, right? You don't really need to know where ozone comes from, right? But the consequences of ozone is something important. Okay, so ozone, as we've already mentioned, already gives rise to photochemical smog, right? It will combine with unburned hydrocarbons and oxides of nitrogen, and this photochemical smog will cause respiratory illness and tearing of the eyes. Okay, this is what happens when ozone is in the lower levels. But actually, there's a benefit of ozone at the higher levels, which we will dive into later. Okay, another important pollutant is carbon monoxide, right? Carbon monoxide comes from the incomplete combustion of carbon-containing fuels, right? For example, your petrol from your motor vehicles due to insufficient oxygen. Okay, and why is this so important to know? Because the consequences is very deadly from this pollutant. Okay, it's very poisonous because your carbon monoxide, right, can actually react and bind irreversibly with hemoglobin in the blood. Okay, and it will form this very stable compound called carboxyhemoglobin. What is affected is the oxygen carrying capacity of your hemoglobin. Usually your hemoglobin will carry oxygen around the body to your muscles so that they can undergo respiration, okay, to produce energy. But now that your hemoglobin has CO, which is carbon monoxide, binded to it, right, it cannot carry oxygen anymore. So you will slowly die due to lack of oxygen, or specifically your cells will die, right? So that's why it's very poisonous. So it's very common to see like people they suffer from carbon monoxide poisoning, right? And then they just die in the end. Alright, and lastly, this pollutant is also very important. This is your sulfur dioxide, right? This is from the combustion of your fossil fuels, right? Like coal, for example, which contains sulfur as impurities. It's very important to know that sulfur as impurities is a must that's inside to produce your sulfur dioxide. Otherwise, there's no reason for sulfur dioxide to come up, right? It needs to have sulfur as impurities. Okay, and another place that it can come out, okay, is your volcanic eruptions. It's also commonly tested as a source. So the consequences of sulfur dioxide is it actually irritates your eyes, it gives rise to respiratory problems, and it can also cause bronchitis. Okay, your SO2 is also a contributor to acid rain, right? It will dissolve in rainwater to form sulfurous acid, which is then oxidized later to sulfuric acid. So these are the two equations that you better know as well, right? And again, we're going to talk about the consequences of acid rain later. Okay, it's also important to understand the composition of clean air, right? In clean air, it contains 78% nitrogen, okay, 21% oxygen, and the rest of the 1%, right, it consists of the following: carbon dioxide, water vapor, and some noble gases, and mainly argon. This is something that you also have to know. Okay, then you have the greenhouse effect, right? So you should be pretty well aware of greenhouse effect by now, okay, thanks to our education system, right? Greenhouse effect is contributed by the greenhouse gases, namely your carbon dioxide and your methane, and sometimes your nitrous oxide, but usually we focus on these two, right? So what do these gases do? These gases actually absorb your infrared radiation, right, that comes from the sun, right, and reduces the amount of heat energy escaping from the earth. In other words, right, these gases, right, are kind of like reflecting back the infrared radiation. So for example, if this is the earth, right, let's just give it a little bit of a land over here, okay? I don't know what kind of land is that, right? And then you have your sun over here. So usually your infrared radiation is going to come down like this, right, onto the earth, right? And that's fine and all, right? But the earth is going to reflect back the radiation usually. So it's going to reflect it back, okay? And most of the time it's reflected back. However, right, sometimes your greenhouse gases, right, are going to, let's say we draw the greenhouse gases somewhere over here, right? This is your greenhouse gases. Okay, if the infrared radiation ever comes here, it's going to reflect it back down like this. Okay, so this prevents the infrared radiation from like escaping the earth, okay, and this causes the warming of the earth. In other words, global warming, right? Because the heat energy is actually trapped in the atmosphere, and this obviously will cause the temperature to rise up on the earth. Now here's a question to y'all. Do y'all think global warming is just purely bad? Right? Now think about this to yourself. If you think that this is purely bad, well, here's a fun fact for you. Actually, global warming is kind of like necessary for your Earth to function. If you don't have global warming, right, what's going to happen to the Earth's temperature is going to drop to like absolute zero levels and very unlivable conditions. So now you can think twice. Actually think about it. Global warming is actually a useful thing to have for the Earth, because it's kind of the reason why you can actually live in it sustainably, right? What's bad for the environment is enhanced global warming. Okay, this is when you're producing too much CO2 in your industrial processes, and you're producing too much greenhouse gases, and the global warming is getting out of control. That is bad for the Earth. So the consequences of your enhanced global warming, just to be specific, right, is the melting of your ice in the North and the South Pole, so the melting of the polar ice caps, and this will cause the sea levels to rise, right? And this will result in flooding in the low-lying countries. Okay, this will also further cause a decrease in the crop yields worldwide, right? Because certain soils will not be usable in terms of cultivating crops anymore, right? And areas that are covered in vegetation may become deserts and just unsuitable for cultivating these crops. Now let's move on to our carbon cycle, right? So our carbon cycle, right, is very important to understand how our CO2 is being produced, okay, and how our CO2 is being absorbed. So they are mainly released into the atmosphere by combustion and respiration. So for example, combustion, like when you're combusting fossil fuels, right, or just pure carbon, it's going to be combusted to give CO2, right? For respiration, this is a biological process that all living things are capable of doing, right? They actually break down glucose into CO2 and H2O, right, with the power of oxygen. Now, CO2 is also absorbed from the atmosphere by this process called photosynthesis. Those of you who do bio should be very familiar with it, right? Photosynthesis, right? In the presence of sunlight, your green plants, okay, that have chlorophyll to convert CO2 and water into glucose and oxygen. Okay, so you will take away CO2 over here, all right? And you should know this equation as well. If you realize it's just the opposite of the respiration equation. So why is the carbon cycle important? If you realize this carbon cycle, right, actually helps to regulate the amount of carbon dioxide in the atmosphere. So your CO2 doesn't go out of control and then you don't produce too much greenhouse gases, right? When you know this cycle, you know which parts to kind of use in order to regulate the amount of CO2. For example, you know that everywhere in this world we're trying to plant more plants, right? And this will help to regulate the amount of CO2 and prevent more global warming. Okay, so for ozone, right? Remember how we talked about the harmful effects of ozone? But there's actually benefits of ozone, right? The ozone, right, actually helps to absorb UV radiation from the sun and prevent it from hitting the earth. So we know how ozone is very useful in the higher levels. The problem is that there's this thing called ozone depletion, right? And this is actually caused by something called propellants in your aerosols. Okay, this is caused by this compound called chlorofluorocarbons. In short, these are your CFCs, right? And these in the atmosphere, right, in the presence of sunlight, right, these CFCs will actually decompose to form chlorine atoms or radicals. These are very, very reactive, okay, and very unstable. So they will then react with ozone, right, to form chlorine oxide and oxygen molecules, and this will inevitably destroy the ozone layer, okay, in this thing called keyword in a self-propagating chain reaction, which is very, very dangerous, right? So with your ozone being depleted like this, right, the consequence of ozone depletion is that the depletion of the ozone layer will allow more harmful UV rays to reach the earth. And as we kind of know, UV rays are very bad because it can cause skin cancer, eye cataract, and even genetic mutation, which is very unwanted. Now we move on to acid rain. As we touched on previously, acid rain is caused by oxides of nitrogen and our sulfur dioxide, right? And we've already touched on the equations as well as to how it's being reacted and produced, right? So your sulfurous acid will slowly be oxidized by oxygen in the air to produce sulfuric acid, okay? And also your oxides of nitrogen in the presence of oxygen and water will be converted to nitric acid through this equation as well. So what's the consequences of our acid rain? Well, once you have this like acidic rain, right, that's falling from the sky, right, and these are actually very strong acids, take note, like nitric acid and sulfuric acid, right, these will actually lower the pH of your soil, kill plants, right, they will lower the pH of water, so they will kill your aquatic life in your aquatic bodies like your lakes, your ponds, right, and these will also corrode your limestone statues and your metal structures through acid carbonate and acid metal reactions. So a remedy for this to tackle against acid rain is that we could use calcium carbonate, right, to reduce the acidity in the soil or lakes. Okay, the reason why we use calcium carbonate because this is generally insoluble, right? So it can react with the acid, and if we ever add calcium carbonate in excess, right, the pH will still be neutral because it just remains insoluble in the water, right, and won't cause any harm, right, compared to using something that's alkali, right? If we add it in excess, we would still kill the aquatic life or it will kill the plants if you add too much of it. Okay, so with all this talk about air pollution, alright, how are we reducing the amount of air pollution? The first method that we have to learn is flue gas desulfurization. Alright, so we will pass these flue gases through a suspension of calcium carbonate to form solid calcium sulfide. This is the way to tackle the production of SO2. Okay, and through this reaction, you'll still produce carbon dioxide, but at least you will get rid of your sulfur dioxide, which is quite a deadly gas. Okay, and sulfur dioxide can also be removed by calcium oxide as well inside. Alright, so through these two reactions over here, which you have to know, right, this will remove your SO2, right, and then your calcium sulfide could also be further oxidized, okay, to calcium sulfate, which is very, very harmless right here, right? Calcium sulfate is just some insoluble compound. And perhaps the most important way to convert some of your harmful gases into less harmful or neutral ones is the use of the catalytic converter. So your carbon monoxide, your oxides of nitrogen, and your unburned hydrocarbons, all of these will pass through the catalytic converter, right? The The catalytic converter will have catalysts like your palladium, your platinum, and your rhodium catalysts, right? And these will undergo catalytic reactions. So your oxides of nitrogen is first reduced to nitrogen gas, okay, through this reaction over here. At the same time, your carbon monoxide is also oxidized to carbon dioxide above, right? So this would happen first, and NO plus CO will give N2 plus CO2. Okay, and N2 is very harmless, CO2 is a greenhouse gas, it's still a bit harmful, but of course it's less harmful than oxides of nitrogen and carbon monoxide. Not only that, right, your carbon monoxide can also fully combust now to carbon dioxide, and your unburned hydrocarbons can fully oxidize and fully combust in this catalytic converter to become CO2 and H2O. So you also get rid of these unburned hydrocarbons. If you enjoyed today's video, do remember to click the subscribe button so that you can enjoy more free content from us and improve your chemistry with us together. If you want to join my community of students to learn more secret formulas to acing chemistry, do check us out in the link below and sign up for a free trial class today.